All right, we're going to compare shapes of skewed data displays in this example. So it's the same thing going on. Customers of a bagel shop complain that some bagels weigh less than the amount on the label. The manager generates a second random sample of 30 bagels. Is a change in the process for making bagels warranted based on the sample? How did this sample compare to the previous sample? So in our last example, we looked at this previous sample and the data was skewed to the left, which meant the mean was less than the median. If your data is skewed, it would warrant a change in the process of making bagels. You could certainly go down that avenue. So the manager says, well, let's do this again. He or she, is it a he? I don't even know if it says, still used 30 bagels, but redid it. And this time the data is skewed to the right. So he got opposite results when he did this again. So this data, oops, about to write opposite. I want to write skewed to the right. So skewed to the right because it trails off to the right. There's a little tail to the right, so it's skewed to the right. When it's skewed to the right, we can infer that the mean is greater than the median, we'll just review the other one. We were skewed to the left. So skewed left, and in this case, the mean was less than the median. So based on the new sample, because the data is skewed and the mean is greater than the median, the manager could say, yeah, this warrants us changing our process. This is what the data shows. However, because it's the second sample and it's the exact opposite of what the first sample showed, the manager now has conflicting findings about the mean weights of the bagels. So you would probably want to reevaluate how to proceed. All right, so we have one more question. What does the shape of the histogram for the second sample tell you about the data? So the second sample was skewed to the right. So we know that. That's the shape, skewed to the right, which meant that the mean will be greater than the median. And the mean for the second data set, they gave us that. If we look, it says that the mean is 97.7 grams. And the advertised weight of the bagels, which would be an average, is 90 grams. So the average weight of the bagels in the sample is greater than the advertised weight. And that's what the customers were having a problem with. So what did we just say? It was 97.7. And what was advertised was the 90 grams. So the mean was greater when it was skewed to the right than what was advertised for the customers.